The mystery deepens as cutting-edge research concerning events at the last glacial termination, especially those connected to the Younger Dryas, is coming to light. 2 new scientific papers are soon to be published. With these papers, it is becoming ever more evident that the transition from glacial to interglacial ages encompasses catastrophic pulses of glacial melting and destruction. The cause of these pulses is, however, unknown, with more pieces of the puzzle revealing themselves. We realize our human past on this planet is way more mysterious than we had imagined. What role does the Younger Dryas play in this unfolding landscape of our cataclysmic past? And what is a Heinrich event? You might want to know about this one. Join me as we square the circle and consider the ramifications of this growing and overwhelming body of evidence, while remember that the past is the key to the future. Well, welcome back to Squaring the Circle. I'm your host and guide, Randall Carlson, and I'm going to be joined in this episode by my friend and colleague, John Arthur, and there he is, who's in the background handling the technology, so I can just think about abstruse and abstract concepts out there in the ethers and don't need to worry about what's actually happening down here in the real world of time and space.
Howdy, Randall.
Oh, hello, John. So we've been talking about number of things. Let's kind of review some of those things we've touched on in the last couple of episodes, primarily the last episode. I know we've been diving into the Younger Dryas events around the glacial termination, and we've talked about the transition from the Pleistocene epoch to the Holocene epoch. And just for the sake of, we're going to be encountering this word frequently from time to time, quaternary. The quaternary is the Pleistocene, Holocene together, right? That's the quaternary, because it was the transition out of the Cretaceous. The final period of the dinosaurs was followed by the Tertiary, right, which was three periods. Then that was followed by the fourth, which was the Quaternary, which consisted of the Pleistocene and the Holocene, and what distinguished those from the previous Pliocene was this oscillating pulse between glacial and interglacial ages. All right, just so we've established that we're kind of referring that as our context for our discussion. These 2 new papers that haven't been published yet. One's going to come out in August and the next one in September. We're going to start with the one in September. It's entitled Rapid Deglaciation of Eastern Maine, Northeastern North America during Heinrich Stadial 1. Published in the Quaternary Science Reviews. It'll be published this September 1st. So it defines the unresolved problem that I've been harping on for decades, okay? This article, penned by lead author Brenda Hall with the School of Earth and Climate Sciences at the University of Maine and 4 other members of the team, begins by succinctly stating the problem in a single sentence, right? And I quote, "Despite decades of research, we do not have a complete understanding of what causes ice age terminations." Then I go on to comment here, I certainly agree, we do not have a complete understanding of ice age terminations. In fact, we might ask, do we even have a partial understanding of what processes are responsible for causing a planetary shift from a glacial to an interglacial age? Or the converse, we don't understand the processes involved in the shift from a warm interglacial planet into the brutal cold of an ice age. I have long held that to get to the bottom of this unexplained phenomena, we must expand our thinking to encompass the cosmic domain. With the publication of the Firestone et al. Paper in 2007, evidence for an extraterrestrial impact 12,900 years ago that contributed to the megafaunal extinctions and the Younger Dryas cooling, we have made a major advance, I believe, towards some kind of resolution of the Ice Age conundrum. But we aren't there yet. The 5 authors of this new paper go on to elaborate upon the paradox, right? Look at the name here, rapid deglaciation of eastern Maine. Okay, what they're doing here is they're saying here, the paradox is that, well, they're about to define the paradox, okay? So it begins with conflicting proxy records for the North Atlantic region during glaciation, paradoxically show evidence of both extreme cold and warming climate during classic stadial periods such as Heinrich Stadial 1, which is dated from 18 to 14.7 thousand years ago, and the Younger Dryas from 12.9 to 11,700 years ago. For example, temperature proxies from the Greenland ice cores and permafrost indicators suggest some of the coldest temperatures of the glacial cycle during these periods, whereas emerging data from glacial reconstructions and meltwater fluxes suggest warming climates. Let's put this in perspective. We've got Greenland ice cores and permafrost indicators together suggest, and oceanic evidence that they don't mention here, but suggests some of the coldest temperatures of the glacial cycle during these Heinrich stadials, they're called here. We're going to come back to what is a Heinrich stadial. But when you look at the data from reconstructions of the glacier, the ice sheets, and you look at the meltwater fluxes, that's not consistent with the extreme cold that they're getting for presumably the same period of time from these other proxies. So there's the conflicting proxy records. So here's the problem in a nutshell. It seems that there is evidence for extreme warmth and extreme cold happening simultaneously, at least within the same year. To provide some resolution to this still unanswered question, Hall et al. Propose what they term seasonality, wherein, as they explain, quote, a proposed explanation of these seemingly disparate proxy records is seasonality, whereby warming summer temperatures during the termination led to glacier contraction and high meltwater flux into the North Atlantic. In turn, this meltwater from the rapidly melting glaciers led to ocean stratification, increased winter sea ice, and extraordinarily cold winter temperatures. Okay, and you and I discussed where we thought this didn't quite add up. I go in my comments here in an attempt to confirm or refute this idea, which they acknowledge is still in its testing phase, quote unquote. They document the behavior of regional glacier ice in eastern Maine. But before proceeding, I'd like to elaborate a bit on what is meant by Heinrich stadials. So just going to Wikipedia, this is what they say, and it's suitable for all the shortcomings of Wikipedia. Some of it's okay, right? And this is one where you're going to find a pretty much consistent explanation, right? A Heinrich event is, first of all, a natural phenomena in which large groups of icebergs break off from the Laurentide ice sheet and traverse the Hudson Strait into the North Atlantic. First described by the marine geologist Hartmut Heinrich, they occurred during 5 of the last 7 glacial periods over the past 640,000 years. Heinrich events are particularly well documented for the Wisconsin glaciation. The icebergs contained rock mass that had been eroded by glaciers, and as they melted, the material was dropped to the sea floor as ice rafted debris and formed deposits called Heinrich layers. unquote. So you can picture the ice is grinding over the landscape, incorporating all of that material up into the ice mass. And now you have icebergs breaking off of the main mass of the ice sheet and floating out into the North Atlantic. And they're floating to the south. And as they float, they melt. And as they melt, all this cargo of this coarse, gravelly, sandy, dirty material falls to the seafloor, accumulates. Then thousands of years go by, and during that long period in between Heinrich events, you have this accumulation where it's the fine-grained, limey material that's the normal accumulation from the water column with all the little planktonic and benthic or bottom-dwelling creatures that make their shells and tests out of calcium carbonate, and they die and dissolve down. And this was eventually becomes limestone, right? But you have these layers where it's very distinct. You can see the fine-grained, with maybe very fine-grained laminae, small particles composing the layer, and then you've got this layer, much thinner layer, of this coarse, gravelly stuff. And we know it had to be iceberg transported because you can take that and analyze the petrology of that material and correlate it with bedrock regions up in Canada. When one considers the mass extinctions of megafaunal species in our past, news stories such as the Maori-led team working to de-extinct the giant moa of New Zealand, it's important to be able to decipher the noise between the proponents and the skeptics. Take, for example, one article from HuffPost, which highlighted the celebrity involvement of Peter Jackson. Yes, the director of The Lord of the Rings. While on the other hand, the Express took a different angle, focusing on concerns about reintroducing a genetically modified predator into New Zealand's wildlands. That's where Ground News comes in. They scanned these two stories and hundreds of others and sorted them by political bias and factual reporting. This lets me quickly identify the blind spots, filter out spin, and compare perspectives at a glance. Now, once upon a time, many moons ago, I'd start my day with coffee and a newspaper. In Georgia, we had two, the Atlanta Journal and the Atlanta Constitution. One leaned conservative, one leaned liberal. As an independent thinker, I read both to get a broader perspective. Eventually, the two papers merged, but thankfully they kept separate editorial pages, so I only had to buy one paper. But here's the problem. I'd end up with stacks of old newspapers to bundle and recycle. And as the price climbed from 50 cents to $2 a copy, I was spending over $60 a month just to stay informed. So I moved on to online news. But even then, getting a full view meant bouncing between a dozen tabs and honestly losing precious time. Ground News solved that problem. With their Vantage plan, I get clean, bias-sorted news from across the spectrum all in one place. Right now, you can get a 40% off their Vantage plan for just $5 a month. Click the link below to subscribe to groundnews.com/TRC. I hope you'll equip yourself with the powerful tool of Ground News just like I have. And in doing so, support our work here at Squaring the Circle. So this is a very interesting idea when you start to picture this, and that's what I want people to. I want people to start picturing that there are these discharges of large icebergs into the North Atlantic. So I go on to say, as with so much other evidence, Heinrich events confirm that the great ice complexes during the glacial ages were subject to massive disruptions, even from time to time undergoing catastrophic collapse. But consistent with the seeming paradox of planetary oscillations between full-blown glacial ages and interglacials, the initial cause of these instabilities are still being debated. As the authors admit, quote, various mechanisms have been proposed to explain Heinrich events, most of which imply instability of the massive Laurentide ice sheet. instability, okay? Probably something on a scale we're not observing in Antarctica or Greenland at present, because we're not seeing either one of those ice sheets disgorging armadas of large icebergs into the adjacent oceans. Some discharge, of course, but not on the scale of Heinrich events, as we'll see. A continental ice sheet covering most of North America during the last glacial period. Now get this, other Northern Hemisphere ice sheets were potentially involved as well, such as the Fennoscandic and Iceland, Greenland. So that's Northwestern Europe. So it's suggesting here that they were potentially involved as well in disgorging icebergs into the North Atlantic from Greenland, from Iceland, and from Northern Western Europe. However, the initial cause of the instability is still debated, right? So don't let anybody tell you that the science of global change or climate change, however you want to term it, is settled science. It's far from being settled. And as I say, once again, we should take note of the deficiencies in our understanding of these extreme climatic environmental events. They go on to say our data suggest extremely rapid, widespread thinning and ice marginal recession of more than 160 kilometers in eastern Maine, centered around this date here. We'll talk about some of this dating in the future episodes, why some of it may be suspect in my mind, because of the unusual nature of what we might call the cosmic environment in which the Earth finds itself. I think some of the byproducts of changes in solar output and galactic ray bombardment may not be so steady state, and they may affect the outcomes of efforts to use things like beryllium-10, carbon-14, optically stimulated luminescence for dating. Okay, but that's not a conversation for now. Combination with offshore ages indicate that this recession was a continuation of that documented as being underway at or slightly before 17,000 years ago. So one of the points they're making here is that you've got many miles of continental shelf exposed during the late glacial maximum, and the glaciers didn't end. The margin of the glaciers calving off these icebergs were not at the modern coastline, but extended out to near the edge of the continental shelf. And then when we're talking now about the recession and thinning of that ice sheet, it's actually starting out there 30, 40, 50 miles further east than the present day coastline. So all of that has to recede first before you even start seeing the evidence of recession on the land, which would show up primarily in recessional moraines, right? The material that's left behind as the ice sheet advances, recesses backwards. So let's see. So you'll notice here that these chronologic data are consistent with rapid ice thinning and recession during Heinrich stage 1, 17.5 to 14.5. And I say I would note that the date for the end of the thinning and recession phase right here coincides with HS1 very closely with the date for Meltwater Pulse 1A. Now, if that's Meltwater Pulse 1A, what it would suggest is that this Heinrich event was associated with this rapid sea level rise. So clearly, you've got rapid recession of the glaciers, 100 miles, right? As it says, extremely rapid, widespread thinning, ice marginal recession of more than 160 kilometers, which is about 100 miles. And then they go on to say that I would note that the date for the end of the thinning and recession phase during HS1 coincides very closely with the date for Meltwater Pulse 1A, and I suggest that we need more in-depth research to what happened around 14.5 to 14.7 years ago. The way out of this paradox, as the authors see it, is that the bitterly cold winters were accompanied by extremely warm summers. While summers may have been warming in eastern Maine, abundant evidence indicates that the winters were bitterly cold during Heinrich 1, at least at other North Atlantic sites. So in this model, the warm summers cause accelerated Laurentide ice sheet melting, which then forms this lid of fresh water upon the surface of the North Atlantic. And then as the authors of this paper explain, while summers may have been warming in eastern Maine, abundant evidence indicates that winters were bitterly cold during HS1, at least at other North Atlantic sites.
So what's their mechanism?
Well, they don't really give one. No. They refer to this as a concept as extreme seasonality. In other
Extreme
words,
seasonality, a hot summer and a cold winter.
A hot summer and a cold winter.
Outside of the normal, somewhat homeostatic.
Yes.
When it's warm, and we're in a cold cycle, but somehow you can have your cake and eat it too.
Somehow.
Without a mechanism.
One would think that a warming signal, at least certainly as what you'd consider, like if warming is the result of the sun, if the warming is the result of somehow extremely enhanced concentrations of carbon dioxide, and I don't think there's any evidence of that showing up during the late glacial maximum until post-warming. Then we see carbon dioxide going up, mostly, I presume, because of outgassing from the oceans because of the post-glacial oceanic warming, right? So yeah, well, this is what I go on to say about it. A couple of observations are in order. First of all, it's not possible to test this hypothesis, and any computer model is going to be limited in its value to the extent we recognize the appropriate parameters. A problem, as I see it, is that if the changing orbital geometries, which are between the Earth and the Sun, which usually most of the climate changes pre-anthropogenic are attributed to these changing orbital geometries, those are slow. They're not going to be, and if they're the dominant process driving long-term climate change, then the warming, because now we're talking about celestial geometry, the warming should be more or less consistent throughout the full year cycle. Why would you have just all the warming concentrated in the summer and then completely disappear during the winter? So it all, to me, comes down upon this idea that this warm water melting off the ice sheets goes over the North Atlantic and then is consequently frozen, because in order to form the lid, it's talking about it's freezing into ice, right? So obviously to freeze that into ice rapidly, which would be implied, you've got to have a lot of thermal energy disappear somewhere and go away, right?
And if it's homogeneous across the entire globe,
correct.
Wouldn't we see evidence in ice cores of a very, very hot summer with lots of melt and then a very, very cold winter? Wouldn't you see this? It doesn't appear to be in the record.
I'm going to pause for just a minute to talk about our partners over at Shippo, who may save you a significant amount of headache in your day-to-day business. We sell a variety of geometry tools and models, like our beautiful platonic solids here at Randall Carlson LLC. And when it comes to managing shipping, e-commerce, and returns, we've been using Shippo for over 4 years now, and we're very pleased with their service. Shippo's interface is intuitive, the primary order page is easy to navigate, and we have enjoyed stellar technical support. If Shippo can help you with your needs, please use the code below to partner with a great company while supporting our work here at Squaring the Circle. Thanks, and now back to the show. So they go on to say this: we attribute rapid recession during Heinrich stage 1 to increasing summer temperature at that time, which would have placed ice in eastern Maine and adjacent areas into a negative mass balance. In other words, it's losing mass, it's melting, losing mass. The contrast between summer warming, as suggested by our data, and evidence for coeval cold winters in the North Atlantic region supports the concept of extreme seasonality during HS1 and likely other North Atlantic stadial events. Okay, does it support that? Well, to what extent is that extreme seasonality hypothesis viable? And I don't think it's viable unless we can invoke some kind of a mechanism causing it, right? Then in kind of conclusion, I say this: the hypothesis of extreme seasonality is interesting. The idea that the annual climate was swinging back and forth between these extremes of heat and cold. The fundamental question I would have concerns what force or forces are driving the rapid melting in the first place. Is it the sun? Is it an extreme uptake and release of carbon dioxide? Is more extensive sea ice in the North Atlantic during the winter months going to generate a global signal? Or is the pitching back and forth between extremes limited to the region of Maine and its contiguous coastal environment? Would it not seem that a summer of extreme warmth would cause the contraction in the time span of winter climate? Would not spring come sooner and autumn come later, just as is now being asserted for the modern global warming? Which implies less time to affect the transition from summer to winter extremes. Well, those transitions now, summer to winter is called autumn, and winter to summer is called spring. So does that mean that fall, autumn, and spring are contracting? They would have to be, because the differential now in this model, say relative to now, is much more extreme. The cold is colder, the warm is warmer, and the amount of energy, of thermal energy, implied by the warmth has to be considerable, because we're losing enormous volumes of ice very rapidly. And in fact, this gets us right back into the mega flood evidence. Then I want to know, one thing I would like to know is how fast is the daily temperature average changing between the time of extreme warmth and extreme cold, compared to, say, for now? What is, take Maine now, that region of Maine, and go, what is the coldest average of the winter and the hottest average of summer? What are the dates? So what is the average increment of warmth or cooling between summer and winter and summer, compared to what this would imply? So that's a very interesting question, and I'm going to, and they have more to say in this too. That's very interesting, particularly deposition of erratic boulders, which we don't have time to talk about now, but we could probably at some point. We are going to be talking about the many proxies of how do we reconstruct and know that there were 6 million cubic miles of ice that aren't there anymore. How do we know that? How can we pretty much prove that beyond any shadow of a doubt? But there's another paper that's coming out next month in August, also in Quaternary Science Reviews. It is entitled Early Holocene Sea Level Changes Along the Western Bohai Seacoast Far Field Response to Meltwater Pulses. Now, you looked up Bohai Seacoast, and you said it was...
The Bohai Seacoast is just to the southeast of Beijing.
China. It's in China. Yeah, okay. Okay, so there's a lot of different interesting regional studies that parallel this one. But we'll just do a short intro to this, and then we'll wrap it up. During the last deglaciation, the global mean sea level rise featured rapid short-term increases. Sea level rapid short-term increases. Now compare that what we just learned from the other paper. Rapid, perhaps, pulses of melting and discharge of icebergs into the North Atlantic. So we have rapid short-term increases superimposed on a longer-term gradual trend, events commonly referred to as meltwater pulses, or MWPs. MWPs studies provide insight into ice sheet melt history and its global impacts, which is vital for improving future sea level rise predictions. Well and good. Meltwater pulses, initially identified through changes in the growth rate of reef crests, right? Particularly this one in Barbados called A. palmato. its growth, it tries to stay right up consistent with sea level rise. So if sea level's rising, it will rapidly build its reef up to stay a consistent depth. All right. The changes in the growth rate include two significant periods of rapid sea level rise. Rapid sea level rise, right, in pulses. Now, these rapid sea level rises are interpreted as the result of, quote, massive, massive continental ice melt following catastrophic ice sheet collapse. Now, what's being described here is a very, very different model of the models that prevailed a half a century ago for the deglaciation process. We can build a little bit of a detour here to tell a story that I think is going to be valuable. I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit. My foot hit it, slid out from under me, and I tumbled down 3 or 4 stairs to the bottom. I sure banged up my left knee. It was painful, but I was very relieved to remember that I happened to pack my CBD from the gods salve. And I was really grateful that I had remembered to do that. So that night, I put some of the salve on, went to bed. Though I've, being in the construction and building industry, I've had many falls and injuries and stuff. And I figured I'm going to be laid up with this for a month. We drove home. I think it was 3 to 4 days later. I continued applying the salve, and I would say within a week, I was getting around pretty good. I always bring the oil when I travel, and I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. One of the interesting I found, I think, very useful. I've saved the abstract here because I think it is useful in some of the insights that preceded the outrageous hypothesis of a cosmic impact at the lower Younger Dryas boundary. And it was published in 2004. Okay, this was entitled Impacts into Marine and Icy Environments, a Short Review. Henning, he's Swedish, he's with the University of Oslo. Henning, it's spelled D-Y-P-V-I-K. D-Y-P-V-I-K. I don't know how you pronounce that. I'm sorry. Henning Dipvik. We'll go with that. Mark J. Burchell and Philippe Clays. Okay, that's a little easier. With the Department of Geology at the University of Oslo, the Center for Astrophysics and Planetary Sciences at the University of Canterbury, England, and the Department of Geology at the Vrije Universiteit Brussels, in Brussels, Belgium. So we got kind of an internet or a European crew there that did this work, and they're presenting at this conference under the heading of cratering in marine environments and on ice. So in this review, we discussed the current knowledge of impact events into marine and icy targets. This includes the major consequences of impact in marine depositional basins and on icy targets. Marine depositional basins is just a more convoluted way of saying in the oceans, right? We also discussed, because I think the reason they're doing that is because you have to include the fact that if it's a large enough impact, it's going to completely penetrate the water column and produce some type of a cratering effect on the seabed, on the ocean floor. Okay. We also discussed some of the future fields of research that could be of interest, in particular, questions regarding triggering of volcanic activity, tsunami generation, and impact-associated petroleum reservoirs. That's a very interesting one in my mind, because the Cretaceous Tertiary boundary, the 66 million year old boundary crater, was first discovered because they were drilling Pemex. Petroleum Mexico was doing exploratory drilling looking for oil deposits there in the northern Yucatan. And what did they come up with? Well, they came up with whatever it was through half a kilometer or so of limestone bedrock that had accumulated in and filled in the crater over the past 66 million years. But at the bottom of this, they discovered this glassy, this vitreous layer. Of course, that was the melt, the melt byproduct of the intense heat of the impact. So they brought up this glassy layer and assumed initially that it was volcanic. And I don't remember how exactly the dots were originally connected between that glassy layer and the actual confirmation of this the subterranean crater form or astrobling that was hiding under the bedrock, but not completely, right? Because there is the ring of cenotes that define the outer rim of that huge crater that's buried. And that's something we should talk about at some point, because a lot of those cenotes became very important to the rise of the Mayan civilization in the northern Yucatan. They were not only places of water and sustenance, but they were also sacred places that they believed were interconnected to the underworld. And they had legends about the cenotes being entrances into the underworld. And there's another example of what we were talking about earlier, where science is sort of confirming in its own way that underlying a lot of the stories and myths and even superstitions, there may be an element of demonstrable truth. And in this case, they were literally performing eschatological ceremonies at the rims of some of these cenotes, like at Chichen Itza, the well of sacrifice. They literally had pipes, hollow pipes, in the form of serpents that they would, with an open mouth on one end, very much like the balustrade at the Castillo in Chichen Itza, the stepped pyramid with its long balustrade, and the serpent, the undulating serpents that formed the balustrades of the two sides of the staircase going up. And the mouths of them are open like that. And so they had these pipes configured very much like that. The mouths would be open and they were hollow. And then there was an opening at the other end, the tail. And they would take the copal resin, which is incendiary. They would put it into the mouth, feed it into the mouth of this serpent or dragon, whatever the case may be. They would light it on fire, and when it was burning, the smoke would pass through the hollow of the pipe and discharge out the end, and they would throw these pipes with the burning copal resin down into the well of sacrifice. They're excavated. There were dozens of these pipes found down on the bottom, because the bottom doesn't lead into the full extent of the labyrinth that goes probably hundreds of square miles. But the well of sacrifice has been plugged up and it's got sort of a clay bottom in it. So all of these ceremonial artifacts that were being thrown into the cenote have been preserved. A lot of them are in the Carnegie Museum. I think they were, a lot of them were excavated during the early 20th century. But in any case, they had this whole ceremonial tradition to try to ward off a repeat of the cataclysm of the world that had wiped out their ancestors. And part of this ceremony would involve lighting these burning resin and throwing, at the appropriate time within the ceremony, throwing these burning serpent effigies with smoke coming out the tail down into the well. And it's pretty clear, even some of the mainstream Mayanists are agreeing that, yeah, this undoubtedly referred to shooting stars, fireballs, and comets, things like that, heavenly apparitions, etc. But the fact that they were associating that with ceremonies that were to remind them, to perhaps minimize the potential for them forgetting, right? Because after all, what did Merlin say to the knights at the when they gathered in their final battle, where they won they had dispatched their enemies, they had established the kingdom of Camelot, and the reign of peace and plenty under Arthur was about to begin. But during all the celebration and the ceremonies and things, when all of the knights are whooping it up, Merlin was there with his burning staff, sticking it in their face, reminding them that what?
It is the doom of man that they forget.
Yes, it is the doom of men that they forget. So we're here in our own humble way to try to remind people, help people, prevent people from forgetting, or reminding people of that which they have already forgotten and bringing it back to memory. So anyhow, let's go on with this quote here. So we find it they presented this paper at this conference, and they say in this review, we discussed the current knowledge of impact events into marine and ice sheets. And I think we can safely conjecture that there's going to be not only differences, but a lot of similarities, because in the tremendous heat of an impact, when you might be talking 2,000 to 4,000 degrees centigrade or hotter at the point of impact, you're going to instantly convert water into vapor, whether that impact is into an ocean or an ice sheet. Either way, right? Anyways, it goes on to say, we also discussed some of the future fields of research that could be of interest, in particular, questions regarding triggering of volcanic activity. Could impacts trigger volcanic activity? And I think there's some very suggestive evidence that would lead us to think that in at least some of the cases, yes, there's a volcanic response to impacts, just as there's a seismic response. Okay, so they mentioned particular questions regarding the triggering of volcanic activity, tsunami generation, and coming up, I'll be doing this interview with Dallas Abbott, who's in the forefront of studying tsunami and discovering evidence for very large tsunamis around the world's coastlines. Tsunamis whose scale and magnitude would suggest that they're not produced by normal seismic or volcanic activity. Okay, so in particular, questions regarding the triggering of volcanic activity, tsunami generation, and impact-associated petroleum reservoirs. In the discussion of the icy impact craters, a summary of the exploration history is presented, both discussing comets and icy targets. An updated schedule for related missions is given, expressing the importance of knowing these processes also for understanding the development of the solar system. Okay, so this, as I said, came out in 2004. So it was anticipating the publication of the Firestone et al. Paper by 3 years, right? Because the implication of the Firestone et al. Paper is that it's largely going to be, at least probably to a great extent, explained, the Younger Dryas, explained by the impact of objects into an ice sheet, into an icy environment. Now that was then just jumping ahead to 2007, the most famous paper was preceded by this one when they discovered micrometeorite impacts in Beringian mammoth tusks and a bison skull. And there's a lot about this on George Howard's Cosmic Tusk website, so I don't think we need to dive into that here. I think we'll skip past that and get right to like it says here, the paper that started it all. In 2007 by Richard B. Firestone, Alan West, James Kennett, and 23 others. And in the abstract, which is too small to read here, so we'll read it together right here. Very important words. A carbon-rich black layer dating to 12.9 thousand years ago. K means 1,000, A means annum or year. So this is 1,000 year, just a short shortcut way. It's just an abbreviation. Anybody who does this kind of work soon knows that Ka means thousands of years ago. So this carbon-rich black layer has been previously identified at 50 Clovis Age sites across North America, and it appears contemporaneous with the abrupt onset of Younger Dryas cooling, which I think this is what we kind of took a dive into the last episode. So there was already established that something had happened here at this boundary layer. The in situ bones of extinct Pleistocene megafauna, along with Clovis tool assemblages, occur below this black layer, but not within or above it. Now, I would say there are a few exceptions to this, but it doesn't undermine the significance of the fact that the vast majority of these remains are found below the black mat layer. Causes for the extinction, Younger Dryas cooling, and termination of Clovis culture have long been controversial. In this paper, we provide evidence for an extraterrestrial or ET impact event at 12.9 Ka, which we hypothesize caused abrupt environmental changes that contributed to YD cooling, major ecological reorganization, broad-scale extinctions, and rapid human behavioral shifts at the end of the Clovis period. So this was the paper that launched I think one of the more preeminent scientific controversies of our time. And of course, it was immediately savaged by the critics. Long before they had a chance to even fairly evaluate the merits of the hypothesis. So we have another paper that comes out in 2008 in the journal Quaternary Science Reviews. And this is provided evidence that there was wildfire and abrupt ecosystem disruption on California's northern Channel Islands at the Alarod Younger Dryas boundary, 13 point, that's supposed to be a point, or to 12.9 Ka. So now what everybody at home listening, go to the world map you have prominently displayed on your wall and put a push pin right there at the California's northern Channel Islands. Okay, so what did they find there? Well, sedimentary records from California's northern Channel Islands and the adjacent Santa Barbara Basin indicate intense regional biomass burning or wildfire at the Alarod Younger Dryas boundary, 13.0 to 12.9 Ka. Multi-proxy records in the Santa Barbara Basin Ocean Drilling Project Site 893 indicate that these wildfires coincided with the onset of regional cooling and an abrupt vegetational shift from a closed montane forest or mountain forest to more open habitats. So before this, you have to picture on these islands, there's forests growing there, the kind you would see forested mountains. After this, then it says to more open habitats. This transition was marked by abrupt ecosystem disruption, which is evident on the northern Channel Islands at the Alarod Younger Dryas boundary, with the onset of biomass burning and the resulting mass sediment wasting of the landscape, which follows it. Oftentimes when you have a landscape that is stabilized by the vegetation, the trees or whatever form the vegetation happens to take, and that is burned off or even, clear cut, well, now that landscape becomes susceptible to catastrophic erosion, right? Because the plants are not there drawing up the excess surface runoff. And so there's nothing to prevent the water from just flowing at maximum with the least impedance to its forward momentum. And the soil is possibly unstabilized. And the result is you have erosion. You have erosional effects, severe erosional effects. These wildfires coincide with the extinction of Mammoth exilis, or the pygmy mammoth. The earliest evidence for human presence on these islands at 13.1 to 12.9 is followed by an apparent 600 to 800 year gap in the archaeological record, which we talked about in the last episode, which is followed by indications of a larger scale colonization after 12.2 thousand years ago. So around 12,200 years ago then. So about a 600 or 700 year gap, which it looks like the whole region that had previously been populated by 50 sites is now abandoned. Population is gone. Although a number of processes could have contributed to a post 18,000 year ago decline in pygmy mammoth populations, we argue that the ultimate demise of M. mammothus exilis was more likely a result of continental scale ecosystem disruption that registered across North America at the onset of the Younger Dryas cooling episode, contemporaneous with the extinction of other megafaunal taxa. Evidence for ecosystem disruption at 13 to 12.9 Ka on these offshore islands is consistent with the Younger Dryas boundary cosmic impact hypothesis. September 2008, so probably right about a year later. Okay. So I think we had this picture here. Did we look at this picture? Right. And then we looked at this, I believe now, same. Now this is in May. So actually this should have been a little earlier in the sequence of slides. But so in May, there was evidence presented by this group from Montana. Montana evidence for extraterrestrial impact event that caused Ice Age mammal die-off. So this is at the American Geophysical Union spring meeting. So this is abstract number. I imagine you could find this online, but I'm guessing if this is in May and the Firestone paper is published in 2007 in, we said October, so we got November, December, January, February, March, April. So we got about a half a year there. Now, here's what I'm wondering. Was this work from Montana already started? Was it already underway before the 2007 paper was published? Or is this subsequent? This group here saw that work and said, well, we're going to go look here in Montana. Well, let's see what they say. Evidence has been found in Montana for an extraterrestrial impact event previously documented in the states of Arizona, New Mexico, North Carolina, South Carolina, and in Alberta and Manitoba. And I think that's referring us back to the Firestone paper we just read. A mammoth fossil site dated at 11.5 thousand years ago, before present, was described in 1969 as the last mammoth occurrence in Montana. The mammoth remains were found in an organic-rich layer, a black mat. The black mat contains abundant charcoal, evidence for forest fire, black carbon glass foam, plant material deposited in a pond, and unrusted iron micrometeorites. Scanning electron microscope photos of iron micrometeorites reveal fusion crusts. In other words, some of them have been fused together, flow lines, and micro impact craters. And we'll see examples of these pictures, which are direct evidence for an extraterrestrial origin. One 140 micron long micrometeorite is 96% by weight iron and 4% by weight magnesium. Or no, that's manganese. Another is 71% iron and 29% titanium. Mammoth tusks contain rusty pits consistent with iron micrometeorites that were embedded and then rusted out. A sample of carbon glass in the black mat contains 62% carbon, 22% oxygen, 6% iron, 4% calcium, 4% silica, and 2% aluminum. I'm sure that everyone already knew that, but I just thought I would go ahead and iterated. At the Indian Creek Archaeological Site near Townsend, Montana, below the cultural layers and below a 11.2 thousand year ago volcanic ash layer, there are individual glass bubbles about 1 millimeter in diameter with micro impact craters. So you've got these small little spherules, and then even on those, there are even smaller evidence of there are craters that were created by even smaller impacting objects. The carbon, here's the upshot though. The carbon glass and micrometeorites suggest a comet rather than a meteorite origin for the extraterrestrial material. Comet rather than a meteor, right? Okay. And then we have at the fall meeting, now we jump from the May meeting to fall in December, the meeting. We have a paper, another team led by M. Fayek, evidence of impact material and the extinction of the megafauna 12,900 years ago. And they say, this is what they said at their presentation, approximately 13,000 years ago, the landscape of North America was very different from what exists today. The Clovis people were hunting mammoths and other megafauna that roamed the land at the close of the Pleistocene. Evidence of these large mammals and the material remains of the Clovis inhabitants no longer appear in the geological or archaeological records after 12,900 years ago. This coincides with the onset of the Younger Dryas climatic event. The onset of the YD appears to have been relatively abrupt, and it lasted for approximately 1,000 years. There have been many theories put forth to explain the sudden changes in climate and human culture, and the Pleistocene megafauna extinction that appear to have coincided with the onset of the Younger Dryas climatic event. Few theories, however, have adequately explained the concurrence of all three events. Nevertheless, few researchers disagree that something major happened 12,900 years ago. So then he goes on to say that in 2007, Firestone et al. Proposed that an extraterrestrial event caused the onset of the Younger Dryas climatic event, the extinction of the megafauna, and the collapse of the Clovis culture. So we've got those three things now that seem to be happening simultaneous. Major climate spasm, the Younger Dryas, Younger Dryas boundary, the major almost final disappearance of the megafauna, the major final spike of mass extinction, and the disappearance of the Clovis culture. Now, what I want to fit into that chronology, if possible, is the relation of that to the whole sequence of mega flooding, which is now dated to have occurred, actually, according to the prevailing dates for at least the mega flooding in the Pacific Northwest, puts it over with at least a millennia or two before the Younger Dryas. I'm wary of that, and very much intend and am looking into more precision on how the dates were arrived at. I know there's beryllium-10 dating has been used, OSL dating, radiocarbon dating. Are they all in agreement? If so, to what extent? And how does the dating of those mega flood events up in Montana and Washington correlate with mega flood events elsewhere? And as we go through, we're going to come back to these two papers that have yet to be published. One will be published next month in August, and another one to be published in not until September. With this paper, skeptics argue that the ET or extraterrestrial markers that have been described by Firestone and others are not sufficient evidence to prove the occurrence of an ET event, because evidence for an ET event, such as an impact crater, tektites, shocked quartz, high temperature minerals, and impact materials are absent. Now, these are all considered to be proxies indicative indicative of cosmic impact. Let's go through them again. An impact crater, obviously the most prominent one, and probably the smoking gun in any controversial example that may exist. Tektites. What are tektites? Well, tektites are part of the splash that comes back down after an impact into a terrain, right? And it usually includes an admixture of both the melted target material and the melted impactor material mixed together. And it's this hybrid nature of the tektites that's quite unique. And they can be microtektites or they can be large things that you can hold in your hand, right? So we have impact crater first, tektites, shocked quartz. Now, we'll be learning about that because that's one of the important indicators of extremely high pressure, pressures beyond anything that otherwise could be produced in nature, whether it's volcanic, earthquakes, pressures along fault lines and so forth, because the failure of most rocks is below the temperatures required to create the fusion crusts and the melted microspherules and so on. So we've got tektites, shocked quartz. When the shock wave, if you have a quartz-rich bedrock and the shock wave is passing through it, all of the quartz crystals ends up with this almost spider web-like formation of internal cracks that are very distinct. So you can, once you've looked at normal quartz and shocked quartz, the difference is pretty apparent. And it is considered to be very much a very convincing proxy for impacts. High temperature minerals and impact material. Okay, so what he's saying is that without any of those, then you can't prove that this happened, right? So they're saying that because they're saying, where's the impact crater? Where's the tektites? Where's the shock quartz? Where's the high temperature minerals and other impact material? Where are they? If you can't come forth with some of that, just get out of here, right? Well, in this paper, they say, here we present for the first time chemical and textural evidence of impact material from the Clovis Age, Murray Springs, Black Mat Layer, Arizona, USA. The impact material consists of iron oxide spherules, also known as framboids, in a glassy iron silica matrix, which is one indicator of a possible meteorite impact. Chemical analysis of these spherules and the glassy matrices found in the particles from the larger size fractions are compared to the chemistry of carbonaceous chondrites, impact material associated with meteorite showers and meteorite craters and tektites, right? The iron oxide-rich glass matrix has an unusually high silicon concentration consistent with the chemistry of impact material from meteorite showers. The chemistry of the matrix is not consistent with terrestrial minerals, but is similar to the composition of a eutectic point. Look that word up for us. E-U-T-E-C-T-I-C. E-U-T-E-C-T-I-C, eutectic point in the silicon dioxide iron what is that? Fe3O4 system with a melting point of approximately 1,500 degrees centigrade. That's the takeaway there. Let's see, what is Fe?
Fe is iron.
Right, I know that. Fe, and so we've got, what is 3 atoms of iron, 4 of oxygen? What does that give us?
It's an iron. That's an iron oxide,
It's an iron oxide. Let's see.
And that's 3 and 4.
Yes, 3.
Yeah, magnetite. That's magnetite.
There we go.
That's magnetite, and the eutectic point is the point of lowest temperature in which 2 materials or 2 substances can be a liquid.
The lowest point. Okay, I am now.
So the eutectic point for iron and something like nickel would be the point at which both of those were still liquefied.
Mm-hmm.
Very hot.
Very hot. So we've got silicon dioxide and magnetite with a melting point of approximately 1,500 degrees centigrade. Such a high formation temperature is only consistent with impact or fulguritic conditions. That's lightning bolt strikes of lightning bolt. However, the chemistry of the glassy matrices of the MS particles is vastly different from that of terrestrial materials such as fulgurites. Okay. So, and right there, I've conveniently, look what I've got down here at the bottom. Eutectic point. So I did my homework, and you know what? I forgot. And you know what else? It's the doom of men that they forget. So I'm demonstrating that right here. It was my doom. No, it wasn't, because I had it right here. I had my backup. The point in a phase diagram indicating the chemical composition and temperature corresponding to the lowest melting point of a mixture of components. And that's what you said. All right. And Fe3O4, iron 3, oxygen 4, ferrosulfuric acid oxide, or magnetite. And a fulgurite is from the Latin fulgur, which means literally lightning. They're natural tubes, clumps, or masses sintered, vitrified, and or fused soil, sand, rock, organic debris, and other sediments that sometimes form when lightning discharges into the ground. So here we go. Okay, so the skeptics have been saying, hey, you guys got to come up with some impact craters or some tektites or some shock quartz or some high temperature minerals or other impact material. And if you ain't got it, we're not buying it. Okay. So here, this team of, probably should look up these guys, M. Fayek, 1, 2, 3, 4. Oh, there's Vance Haynes. I recognize his name, L. Bergen. So 1, 2, 3, 4, 5. A 5-person team presenting at the American Geophysical Union fall meeting presented evidence, maybe the first salvo of evidence supporting the idea of a cosmic impact. Well, you asked for high temperature minerals. We've got some high temperature minerals for you that we found in Montana, and it looks like it falls right on that marker. So then the same year, here's Ted Bunch, the late Ted Bunch. I was sorry when I never met him, but I was looking forward to meeting him. And he was also one of the founding fathers of studying impact proxies and being able to identify the signatures of hypervelocity impacts. Whitkey, there's Alan West, there's Jim Kennett. This is probably his son. Hugh He, S.S. Wolbach. She has done some really good work. Let's see, anybody else? Well, it's a very sophisticated group of people that have come together, and they're presenting hexagonal diamonds, which are also called, in this particular form, Lonsdaleite. Look up Lonsdaleite for us. Interesting, named after a great scientist. What was her name? Lonsdale?
So Lonsdaleite is a rare hexagonal form of carbon, an allotrope of diamond, also known as the hexagon diamond.
Okay.
Found in nature primarily in meteorites.
There we go. Okay.
It's formed under extreme pressures and temperatures, such as those found in asteroid impacts. There you go.
So this, which was published in 2008, you can see what some of these guys are working on. This is the KT, or Cretaceous Tertiary Impact Layer in Spain. So the reason this is significant is because they found these shocked hexagonal nanodiamonds, or Lonsdaleite, found in concentrations greater than 50 parts per million at Needle Points, New Zealand, and Caravaca, Spain. This is also the first evidence for KT diamonds of any kind outside of North America. No diamonds were detected immediately above or below the impact layer. Now, this is the KT boundary, 66 million years ago. Cubic diamonds have been reported earlier from North American KT sediments by Carlyle and Brahman in 1991 and Howe and others in 1997. But Lonsdaleite was not detected. Carlyle and Brahman suggested that the cubic diamonds arrived already formed within the impactor, but Howe argued that they were shock produced by the impact with Earth. And I think the consensus now is that they're produced as a consequence of the shock impact. Hence, it is not yet clear that KT cubic diamonds, and that's one of the characteristics of the Lonsdaleite, is they're cubic, were formed through shock. Lonsdaleite does not co-occur with terrestrial diamonds, but is found with cubic diamonds in ET impact craters such as Popogai, which is in Siberia, and Sudbury, which is up in Ontario. Both also, and here's the what I should have underlined. Both also have been reported in the impact layer of the proposed Younger Dryas impact at 12.9. And in fact, it turns out that the nanodiamonds found at the KT boundary, their closest analog with other impactors and impact events, is the ones found at the KT boundary 66 million years ago, which to me is very interesting. And this relates to what we were referring to discussing last episode. This is, again, a lot of stuff getting published in 2008 in the immediate aftermath of the Firestone paper. Look at here. Biostratigraphic evidence supports Paleo-Indian population disruption at 12.9. And this, to me, is where it gets really interesting, is where it's one thing to look at these kinds of events in the abstract, but then when you bring it home and you go, how did this affect humans and human populations? And then you realize, well, it did, probably in really profound ways. Let's see. Buchanan and others interpret an approximately 40% reduction in the cumulative probabilities of radiocarbon dates at the beginning of the Younger Dryas as noisy data inconsistent with human population decreases predicted by the extraterrestrial impact hypothesis. This reduction is, in fact, consistent with other biostratigraphical evidence, suggesting an abrupt environmental perturbation at the onset of the Younger Dryas affecting human populations. Haynes described a black sedimentary layer at 70 localities across North America, dating to approximately 12.9 Ka as a stratigraphic marker horizon, where Clovis artifacts and selected Rancho La Brean fauna occur just below but never within or above. And down below, I have Rancho La Brean, a valuable term to know. It's the Rancho La Brean North American land mammal age. On the geological timescale is the North American faunal stage according to the North American land mammal ages chronology, typically set from less than 240,000 years to 11,000 years before present, a period of 0.229 million years. It's named after the famed Rancho La Brea fossil site, more commonly known as the La Brea tar pits in Los Angeles, California. The Rancho La Brean is characterized by the presence of the genus bison in a Pleistocene context, often association with other extinct Pleistocene forms such as Mammothus. So as he's saying here, the Clovis and the Rancho La Brean fauna occur below, but never within or above this black mat layer. So going through this, the sake of keep moving here at a good pace, Folsom age material. So this is a different culture. After the abandonment of these sites by the Clovis, 500 or 600 years goes by, and then you have what appears to be a different culture showing up. So let's see. Of the 11 well-dated credible Clovis sites, none has post-Clovis materials immediately above, suggesting a potential disruption in settlement or landscape use. Folsom age materials occur above the Clovis materials, but a hiatus of approximately 500 years is suggested by an intervening sterile deposit, 10 to 35 centimeters in thickness. So you've got this sterile deposit. You've got the black mat layer, Clovis below it, Rancho-Bran and other extinct mammals below it, a sterile layer, and then you have appearance of a new cultural group that looks to be in many ways distinct from the Clovis after this period of 500 or 600 years. And it says this is also the case at the well-dated Clovis deposits at Shawnee Mini Sink from 12.9 to 12.8 thousand years ago in Pennsylvania, which are separated from an early archaic deposit from 11.5 thousand years ago by 171 meters of sterile deposits. So 1.71 meters, let's convert that to feet. We get it as that here, 1.71 times 3.28. So that's over 5.5 foot thick layer of sterile deposits. But you can also see that the span of time before the reoccupation is longer. What did it say? Well, from until 11.5.
500.
So yeah, I mean, so that's over 1,000 years, 1,300 years, something like that. But then the layer of sterile deposits is obviously thicker, more time has passed. But it says, it concludes, when biostratigraphic and radiocarbon evidence are taken together, they point to a post-Clovis decline in human populations consistent with the Younger Dryas impact hypothesis. So, want to pause for a minute and make a few questions?
How long before you think this will actually take root and form in the academic circle?
Well, I think it's happening, but we're probably a decade out. I would think it has to have been worked its way through this paradigm shift within a decade, because there's too many, it's getting too well known amongst too many smart young people that are moving into the fields of geology and archaeology and astronomy and planetary geology and paleontology, that are willing to consider ideas beyond the 20th century consensus that had emerged out of the late 19th century strictly gradualist models that encompassed everything from geological change, rates and magnitudes of geological change, as it also applied to biological and zoological change. In that, with the advent of Darwinian evolution occurred, it's important to realize and understand that the advent of geological gradualism / uniformitarianism and its establishment as an academic discipline was almost exactly concurrent with the rise of Darwinian evolution and its establishment as an academic discipline that viewed all biological change in terms of small, almost non-discernible incremental changes that ultimately led from one species to another species that what necessarily within that model represents the two endpoints of a continuum, and that the accumulation of changes that differentiates between two species, which are now not viably able to reproduce anymore, which I think is the primary fundamental idea now, at least pre-genetics, using the genetic code as definition. I think the idea of species was if they're the same species, they can co-reproduce. When they can't do that anymore, then they're different species. But it almost seems that the implication there is that within these two endpoints, you've got this long, slow, almost indiscernible accumulation of incremental changes, right? Well, that's exactly the same model that applies to gradualist geology, right? The landscapes that we're looking at now are the end point of a long, continuous process of incremental change. And sort of the tagline of that was, geology proceeds by one drop of water and one grain of sand at a time. This was literally the model that was promulgated in textbooks not so long ago. And again, the end result of this is the landscapes we see today. Conversely, as we look at the landscapes we see today, they are the end result, the end product of this long, almost invisible process of slow. Now, yes, it can be punctuated by a local event here and there, yes, but these are merely blips within the broad field of stasis, of continuity. See, we know that now is not the case anymore. As we also know that there are saltation, there's quantum leaps, inexplicable quantum leaps within the ascent of life forms on Earth that, to me, confound the ability to explain away the presence of life as just being the long end process of incremental biological changes happening at random. Anyways, so this paper was actually proposing to be a critique of the, which appeared in 2009, a critique of the impact hypothesis, but in my opinion, it supports. It's a long team here, but wildfire responses to abrupt climate change in North America. It is widely accepted based on data from the last few decades and on model simulations that anthropogenic climate change will cause increased fire activity. Now let's pause right there because I think you can see very first sentence. They've established the parameters of this particular study. That's a given, see. Now working from that's your working premise. Well, now you can see how I think they kind of contort the evidence to fit that premise. But let's go on and see what they say here. However, less attention has been paid to the relationship between abrupt climate changes and heightened fire activity in the paleo record. We use 35 charcoal and pollen records to assess how fire regimes in North America changed during the last glacial interglacial transition from 14 to 10,000 years ago, a time of large and rapid climate changes. So they're acknowledging the reality of large and rapid climate changes, right? But they're immediately, by using the term climate change, they're using it within its restricted meaning, which we know since the 1990s, first global warming got replaced by, which was clearly inferential of human activity, to climate change, which could be a much broader term talking about anything and everything going back with no given limit of time span, right? Thereby clearly implying non-anthropogenic, non-human caused climate change. But however, with the hijacking of that term and all acceptable discussion from that point on, climate change came to mean human climate change, human caused climate change. Never mind the rest, okay? So they go on here to say, we also test the hypothesis that a comet impact initiated continental scale wildfires at 12.9 Ka. And then they say the data do not support this idea, nor are continent-wide fires indicated at any time during deglaciation. There are, however, now this is where the caveat, I think the unintentional caveat comes in. There are, however, clear links between large climate changes and fire activity. Now, they're admitting, there are links, clearly discernible links between, what do they say? Uh, large climate changes and fire activity. Okay, but there's no data to support the idea that fire activity is associated with an impact, but there is data to show that it's associated with large climate changes. Okay. Biomass burning gradually increased. That's one of the important operative terms, gradually. Okay. The biomass burning gradually increased from the glacial period to the beginning of the Younger Dryas. Okay, then what happened? Uh, Although there are changes in biomass burning during the Younger Dryas, there is no systematic trend. There's a further increase in biomass burning after the Younger Dryas. Intervals of rapid climate change at 13.9, 13.2, and 11.7 thousand years ago are marked by large increases in fire activity. The timing of changes in fire is not coincident with changes in human population density or the timing of the extinction of the megafauna. Although these factors could have contributed to fire regime changes at individual sites or at specific times, the charcoal data indicate an important role for climate, and particularly rapid climate change in determining broad-scale levels of fire activity. Okay, so they've established pretty clearly, or have concluded, that there is this very strong connection between large, rapid climate changes and broad scale levels of fire activity. Let's see here. It goes on to say, it is generally asserted that anthropogenic climate change will lead to widespread and more frequent fires. Now, I don't necessarily agree with that, but that's a whole other question. But again, you can see the inference here. They are operating from that assumption. Climate change is being produced by human activity, and it will increase fire activity in the future. Data from Western North America in recent decades are consistent with this. They show that increases in the frequency of wildfire and the duration of the fire season are linked to increased spring and summer temperatures and earlier spring snowmelt. But then they mention about changes in the pattern of precipitation are likewise affecting fire activity, as is the development. And now this is important because they choose to downplay this factor that they're about to mention, whereas I hold that this factor is of preeminent importance, right, in the high levels of fire activity. So there may be changes in pattern of precipitation affecting fire activity, but there's also the development of high fuel loads associated with long-term fire suppression. That sink in, right? High fuel loads associated with long-term fire suppression. So right there, long-term fire suppression is referring to the long-term human activity of suppressing forest fires as soon as possible, as soon as they were able, as soon as they were detected, right? So as a result, you have high fuel loads. Now, in a lot of the western forests, there have been, for example, insect blights. Northern California, parts of Oregon have thousands upon thousands of acres of dead trees as a result of insect blight, right? What happens to those dead trees? Well, they become part of the litter on the forest floor, and that becomes the part of the fuel load. Now, at this point, it's well known that Native Americans regularly burned off excess fuel. Many tribes did this. It was an integral part of their life within the North American ecosystem, right? Well, the Smokey Bear, prevent forest fires, that whole ethic of suppressing forest fires. And then restricting access to these forests, which would have allowed harvesting of the dead timber and the removal of the human from these forests actually has contributed to the emergence of these catastrophic firestorms. For example, this is not to say that there's an argument in favor of clear cutting, although in some limited cases, clear cutting can be very interesting and valuable for creating the types of habitats that are conducive to certain species that rely on a mosaic that you might have naturally occurring when you have forest stands interspersed with with meadows areas and open areas or savanna areas, right? Um, so it's not altogether a bad thing if it's limited, but certainly, selective cutting as you would do in silviculture, for example, where you're actually managing the harvesting of the forest. The whole environmental movement since the early 70s has had this kind of hands-off ethic. So a lot of the companies that were harvesting timber up in the Pacific Northwest, for example, got shut down. Well, they had access roads that they had cut in that allowed them access for their harvesting equipment and their trucks and so on. Well, once that the forest, a lot of these forest areas became off limits, those logging roads that had existed there, they grew over. Well, a lot of times during forest fires, the fire suppression equipment would be brought in and they would use those logging roads, right? Well, now you've got restricted access and you've got the accumulation of this huge, very incendiary fuel load. And both of those things are the consequence of policy. They're human intervention into the system in ways that are, to use a polite term, suboptimal. Okay. So anyways, it's interesting here to read this because they're admitting here changes in the pattern of precipitation are likewise affecting fire activity, as in the development of high fuel loads associated with long-term fire suppression. Um, uh, yeah, the effects of climate variability on fuels and fire regimes on multiple timescales have received much attention. And some research has linked shifts in fire regimes at individual sites to rapid climate changes. But clearly, we're talking about fires being linked not with human induced changes, but natural. By inference, these are natural. These these individual sites of rapid climate change, which is now indisputable. However, the broad scale response of wildfires to large abrupt climate changes in the past has received little attention. One period of particular interest, now get this, one period of particular interest is the last glacial interglacial transition, 15 to 10,000 years ago, when large and sometimes abrupt, spanning from decades to centuries, changes in climate and biota occurred in many parts of North America. In some regions, environmental changes at the beginning and end of the Younger Dryas chronozone, in particular, were larger than those at any subsequent time. Well, they've just admitted. They said there are multiple episodes of widespread fire activity associated with rapid and large climate changes. And then they say, but in some regions, environmental changes at the beginning and the end of the Younger Dryas chronozone, in particular, were larger than those at any subsequent time. So I'm not seeing here that they have refuted any of the evidence for comet hypothesis. Yeah, so
If anything, it complements. I wouldn't use the word support, but it complements. There's nothing negative here.
Yeah. Even without invoking catastrophic events such as a comet impact, there are still reasons to expect a broad-scale response of fire activity in North America to the abrupt climate changes during the late glacial, interglacial transition. So, and then they go on to say this. At the beginning of the Younger Dryas chronozone at 12.9, North Atlantic meridian overturning slowed or shut down. This led to abrupt cooling in the circum-North Atlantic region and general changes in atmospheric circulation around North America. Well, this gets us to this massive influx of meltwater into the North Atlantic that is considered to be responsible for the shutdown of the thermohaline circulation. So we can't just isolate the thermohaline circulation shutdown from all the rest of this stuff that's going on, because it brings us back to the question of why is there so much meltwater being introduced into the North Atlantic? And that's what these two new papers are addressing. So it goes on to say this led to abrupt cooling in the circum-North Atlantic region and general changes in atmospheric circulation around North America. Because atmospheric circulation affects temperature, precipitation, and the position of storm tracks, the particularly abrupt onset of the Younger Dryas chronozone was registered across the continent. A large rapid climate reversal occurred in regions adjacent to the North Atlantic. How is this? I mean, I'm not seeing how this in any way refutes the idea of an impact. Anyhow, it seems to me that they're acknowledging here the particularly abrupt onset of the Younger Dryas. So they're saying that these broad-based fire regimes are associated with abrupt changes in climate. They're then saying that the Younger Dryas was a particularly abrupt onset across the continent. So I just find that interesting. But then phys.org, in response to this paper, comes out with this. And this is why I think this is significant. Here's the heading. You can see it right here. Comet impact theory disproved. New data published today disproves the recent theory that a large comet exploded over North America 12,900 years ago, causing a shock wave that traveled across North America at hundreds of kilometers per hour and triggering continent-wide wildfires. So yeah, you can see the spin right here. Dr. Sandy Harrison from the University of Bristol and colleagues tested the theory by examining charcoal and pollen records to assess how fire regimes in North America changed between 15 and 10,000 years ago, a time of large and rapid climate change. Here we go. Their results provide no evidence for continental scale fires, but support the fact that the increase in large-scale wildfires in all regions of the world during the past decade is related to an increase in global warming. Well, there you go. I mean, is this legitimate science that we're looking at here? I mean, we just went through one of these papers that is being invoked as proof. And where was the proof in there? I mean, we could have analyzed the whole paper, and I think even going through the whole paper and coming up to the conclusions like I've done. Where's the proof? Right? In anything that we examined, did you see anything disproving the possibility of a comet impact? I didn't.
There's no real delineation between opinion and fact there.
Right.
It's just their opinion.
They're they're acknowledging right here, the end of the Younger Dryas about 11,700 years ago was an interval when temperature of Greenland warmed by over 5 degrees centigrade in less than a few decades. It may have been in less than 5 years, and it may actually have been more than 5 degrees centigrade. But anyways, they used 35 records of charcoal accumulation in lake sediments from across North America to see whether fire regimes across the continent showed any response to such rapid warming. They found clear changes in biomass burning and fire frequency whenever climate changed abruptly, and most particularly when temperatures increased at the end of the Younger Dryas cold phase. Wait a minute, what? They found clear changes in biomass burning and fire frequency whenever climate changed abruptly, and most particularly when temperatures increased at the end of the Younger Dryas cold phase. Wait a minute.
Chicken or egg? What started the fires?
Yeah, so it just seems to me that, yeah, I mean, having read this paper and looking at this, you can almost see, well, yeah, here's evidence that actually, in my mind, supports not necessarily an impact, but supports the idea of some catastrophic, at this point, unexplained catastrophic event. So I would ask these people, what you say, okay, you can see fire changes in the fire regime every time there's an abrupt climate change. Well, what's driving these abrupt climate change? I mean, I don't think the Clovis culture are driving SUVs. At least we haven't found any evidence that they were.
Why is there a change in the fire regime? Whereas it's been stable, been at some homeostasis all the way up until this rapid episode of climate change.
Yeah. So
what's driving the change?
What's driving the change? What gets back that gets what gets us back to the question. Yes, I guess we'll continue on here. So we've got back to Ted Bunch, Whitkey, West, Kennett, summary of impact markers and potential impact mechanisms for the Younger Dryas boundary impact event at 12.9. The discussion here is, and this appeared at the American Geophysical Union fall meeting of 2009. The discussion here is limited to possible origins of the impact markers, and not with impact consequences such as climate change or extinction. Several origins may account for impact materials in the YDB. One, an extraordinary accretion of micrometeorites, which was proposed by the two leading critics, Pinter and Ishman. Right. However, this is inconsistent with Younger Dryas boundary carbon spheral compositions, including the large concentrations of nanodiamonds found embedded in those carbon spherals. Two, oblique impacts into the Laurentide ice sheet. This model is consistent with the lack of a visible crater and apparent lack of cratering markers above, and yet also provides for shock production of the many cubic nanodiamonds and Lonsdaleite found in the Younger Dryas boundary. And then three, impact-induced aerial burst. And I think it's a combination of both aerial bursts of the smaller stuff and actual impacts into the ice sheet and possibly into the North Atlantic itself by the larger macro scale objects. Because I would argue that I think the evidence is consistent with a multi-impact event rather than a single isolated random event. The lack, from the same paper, the lack of high shock pressures in an aerial detonation does not necessarily preclude the formation of cubic and hexagonal diamonds, as shown by Maruyama and others in 1993, who made hexagonal and cubic diamonds by a CVD process. This is carbon vapor deposition. Let's not go into that right now. By a CVD process from a high temperature plasma atmosphere, 13,000 degrees centigrade, under pressure conditions similar to those in an aerial burst. The Tunguska event is commonly accepted as a result of a near-surface aerial burst and has many similarities to the Younger Dryas event. That's why I think it's important to have conversations about the Tunguska event in the context of the Younger Dryas event. Then we have comet grazing of the atmosphere involving nearly tangential entry, meaning very low angle, right? Just skimming through like stones skimming on water across the atmosphere. And we talked about that last time.
The 1913 event.
Exactly. This is why I'm hoping people will refresh themselves by actually listening to some of these lectures and presentations several times to really, if that is, if they're really interested in learning it. And to me, the excitement and the interest and the mind-blowing interest is when you really begin to learn and get the picture of these events in your mind. And I'm hoping this might inspire a lot of young people to follow some of these many pathways into the scientific realms that's going to help to bring more light on these still unresolved, perplexing questions about planetary changes and their effects on humans. But comet grazing of the atmosphere involving nearly tangential entry of a comet into the Earth's atmosphere with partial detonation and melting, followed by escape of the unexploded nucleus into space. This has the net effect of an atmosphere penetrating aerial burst, followed by a global fallout of detonation products. 3 of the 4 above scenarios are plausible. And this is one that I think is going to it'd be worth devoting more time to than we'll have for what remains of this episode. But this was considered to be one of the death knell. When this was published, came out in 2009, this was considered to be the death knell of the impact hypothesis right here. Because after this, Todd Suravel, Vance T. Holliday, and the rest of these people published this paper, the consensus shifted, and now pretty much most of the commentary that you saw in mainstream media was, oh, well, this whole theory, this whole hypothesis has been overthrown because we had an independent team of experts go out there and they were not able to replicate the findings. So because this was used, and it's exemplary in its usage as a means of a debunking without really debunking, and why it's worth unpacking what happened here, and then the response to this paper and why they it says it's an independent, right? And we'll just look, you can see where it's going. Based on elevated concentrations of a set of, and they have them in scare quotes, right? Impact markers. So right there, you don't have to read any farther. You know where they're going with this thing. Based on elevated concentrations of a set of impact markers at the onset of the Younger Dryas stadial from sedimentary contexts across North America, Firestone, Kennett, West, and others have argued that 12.9 Ka, the Earth experienced an impact by an extraterrestrial body, an event that had devastating ecological consequences for humans, plants, and animals in the New World. Herein we report the results of an independent analysis of magnetic minerals and microspherules from 7 sites of similar age. That's an important admission right there. Of similar age. What do you mean by similar? Right? I mean, if we're talking about a very narrow band, a very narrow stratigraphic marker horizon, we're not talking similar age. We're talking, we have to be precise here, right? Because we're looking at something that's not going to span more than a few years between the time of the impact and whatever deposition of material ends up in the stratigraphic record is only going to be a few years. I mean, it's very possible that if similar in age means 5 years or 10 years, it might in fact imply that you're not even sampling from the right layer. See, and I think we can actually demonstrate that this was part of why they were not able to replicate. Herein, we report the results of an independent analysis of magnetic minerals and microspherules from 7 sites of similar age, including 2 examined by Firestone and others. We were unable, we were un, excuse me, we were unable to reproduce any results of the Firestone et al. Study and find no support for Younger Dryas extraterrestrial impact. I'll read that again. We were unable to reproduce any results of the Firestone et al. Study and find no support for the Younger Dryas extraterrestrial impact. Well, this was considered a follow-up article on this one was actually entitled Requiem for the Younger Dryas Impact Hypothesis. And I think it's very instructive to spend a little bit of time going through this, right? Because one of the things that you can see, particularly in those who've not gone into the level of detail necessary to have an informed opinion about these matters, are just too ready to latch on to whatever they happen to see as the latest profferings of mainstream media. Because I saw a lot of people after this came out going, oh, well, it's been disproved. It's a bunch of bunkum. It's hooey. Alan West is a fraud. They were saying that, you know, on all of that, attacking him personally. Just pure BS, right? But then when you take a look at the protocols of their independent evaluation, it doesn't tell the same story. And I think maybe we would do that. Spend 15 or 20 minutes in the next episode looking at that. The 2 new papers that have come out are not specifically aimed at proving or disproving the impact hypothesis, because there's been a tremendous amount of research. We talked about it in a recent episode when we talked about the discovery in Louisiana, right? And
the Perkins impact.
The Perkins impact and the one in Russia. So there were two new papers that have come out, one supporting with more proof and evidence from Louisiana, another one from Siberia. I cannot underestimate the significance and importance of this information for us to understand the larger scale picture of the terrestrial and cosmic environment in which we find ourselves, the particular theater of our own cultural evolution, if you want to put it that way. Because the history of civilizations on this planet has not been this nice, smooth, logarithmic curve leading to the ascendancy of our modern status. What we see, what is emerging and consistent with the majority of the evidence now in hand, is a sawtooth. We see civilizations rising, achieving levels of sophistication and glory and advancement, and then boom, they're gone. And usually we can look at 10 or 12 different cultures and see the same pattern. Their disappearance is very rapid and in some cases very complete. I would submit that it's critically important that we understand the larger natural cycles of which we are embedded, of which we are an indelible part. And if we don't understand those cycles, it's going to seriously abort our future potential for long-term sustainability as a civilization on this planet. So therefore, I hope that you're continued to be willing to explore these topics in depth. I think what we're doing here is we're exploring this material really in a popular format, in a popular venue, more deeply than anybody else that I know out there. Now, I know there are others. Yeah, I mean, George is doing a great job over at
Cosmic Tusk.
Yeah, and there are others. And we'll be connecting with those, linking to those sites, and sharing information. Certainly, we have met, at the Cosmic Summit that I just returned from. I met, was able to hang out with Malcolm LeCompte, with Stephen Collins, who's doing the work at Tel El Hammam, the very significant work at Tel El Hammam, and others that I've met there, that we will probably be Dallas Abbott. I think she will be coming on in a very near future episode. We'll have her as a guest. We can talk about her work with tsunamis, and tsunamis that are probably too large to have been generated by earthquakes or submarine volcanic eruptions. So that's what we're going to be getting into. I hope people stay with us for this. I know there gets a lot of detail in here, but don't forget, God is into details, as has been said. So I hope some of you stick with it. And interestingly, the more you stay with it and the more you understand and formulate this picture in mind, the more interesting it gets. Because for one thing, this is an unresolved scientific paradox of preeminent importance that has not been solved yet, has not been worked out. We've got some important leads, no doubt. And I do think that the extraterrestrial hypothesis is going to prove to be the viable one in the long term. But it's still not proven to the satisfaction of a lot of scientists. And one of the things I would submit before we go here is simply this, that I think that modern science is proving what maybe has come down to us and is now called geomythology and astromythology. That a lot of the ancient stories and legends and traditions that have been handed down from old contain valuable insight that can help us get a better and deeper understanding of these events from the scientific perspective. So we'll definitely be talking about some of that as well. So this is Squaring the Circle. Please like it and subscribe. I got to warn people that we are going to be starting to do a few ads coming up, because that's going to help us do more of what we're already doing, bring more material in a more interesting and powerful way to the forum of public discussion. That's what it's going to allow us to do. And plus launching some other very interesting plans that are in the pipeline. So with that, I don't have anything else to say, John, and I've done most of the talking tonight. I've given you a break. Do you have any last final punctuation marks you want to add?
Well, I think you and I were talking about this before, and we mentioned it in the middle of this, but I'll say I'll leave it to you to say one more time. What was Merlin's famous quote after the everything was said and done? What was Merlin's big warning to the men of the round table?
Well, I actually could share a slide that I modified from a piece of art that was a book cover of a book that I would highly recommend. And the quote is from Merlin, and he says, "It is the doom of men that they forget." So on that cliffhanger, we'll adjourn for this episode, but we'll definitely be coming back around to pick up the baton where we left off, pick up the thread in Ariadne's labyrinth.